This is the Argon News Network, where today we're going for the core. Welcome, hackers and hackettes of the Argon Light 8-bit retro modern thingy community. Today we're hacking the kernel. We are attacking the master control program. So let me paint you a picture. You're at a stylish cocktail party. You have your glass with like half a fruit salad and a plastic monkey hanging out of it. You're making good progress with a member of your favored gender. Don't judge. He, she, or they, they got the dreads, they got the tattoos, I'm up here, hot, 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 right? And you're about to hit them with one of the patented Argon pickup lines. We should have a contest about Argon pickup lines. I'm sure there's some out there to be made. And in that moment, he, she, or they will say, oh my God, I would never date anyone who doesn't compile their own operating system. Yeah, okay, maybe not super realistic scenarios, but I have been told that Gen Z is a bloody weird place to be these days. More realistic scenario. You're at an interview, you've made it to the final round, and unfortunately the people interviewing you actually read your CV. And somewhere at the bottom, behind the sort of Minesweeper consultant and solitaire expert MCSE kind of certification, and you're an Excel expert, and you're this and that and the other, you put like operating system hacker or kernel hacker just because, right? And now they're calling your bluff and say, well, when was the last time you compiled an operating system? What are you going to do now? Because, well, if on Mac OS, closed source, can't compile it. Windows, closed source, can't compile it. Linux, you can compile it, but one reason why Linux kernel hackers have such long white beards is because it takes forever to compile it. It takes forever to learn how to compile. I've done it once or twice in my life, and I don't really want to go back there. So what do you do? Haha! Argon to the rescue! Because today I'm going to show you how to compile your own version of MOS operating system for the Argon Light. How cool is that, huh? So let's dive right in. The tools you're going to need, the emulator is recommended but not necessary, just to test, rather than flashing an experimental operating system and bricking your device potentially, which is not completely terminal but inconvenient, just test it in the emulator. You need a hex to bin because the compiler outputs a hex file and MOS needs a bin file. You need the actual compiler, which is the Zilog Developer Studio 2, and it's the Acclaim edition. So EZ80 Acclaim exclamation mark. I've had more success with version 5.3.4, maybe because I installed it firm. No, good luck. But 5.3.4 works for me. Download it from here and install it. And then, of course, we need the actual operating system. Quick note on the ZDS though. ZDS is amazing. When you install it and just click next, it doesn't give a damn. It creates a folder on the root of your C drive on Windows, right? The root of the C drive. None of this program files, program 86. No, heck you. I'm a Z80. I was there before the 8088 and the 386, 486 Pentium. I'm older than any of you. I install wherever the heck I want. I personally would recommend leaving it there because when you download projects of the internet, they tend to assume that it's going to be at this location. If you have problems building and it says missing file or something, and you see that Zilog, that's where your problem is. Then you need to adjust the relevant path in the configuration files. So yeah, Zilog, the honey badger of compilers, because it doesn't give a damn. Honey badger doesn't give a damn because it just installs where it wants. And then you need the actual code, maintained by Dean Belfield, our favorite Steve Wozniak impersonator, slaving away, currently making a 24-bit BASIC on an 8-bit computer. I don't know exactly how that works. Because I could do this with GitHub Desktop because I finally got it installed, but we're going to do it the brute force way. Download the source code as a zip file. Whoops, a daisy. Downloads. There we go. Extract that zip file into the downloads folder because all professional software development does take place in subfolders of the downloads directory. And then we go down there. There it is. There's all your stuff. So then we start the ZDS development environment. Here it is. And then we open the, whoops, daisy, come back here. We open the project. And are we there already? Yep, it's already there. So we go to the project, we open MOS. And here it is. This is one I prepared earlier, and here it is already. Remember, you're in your interview, and you're there. Oh my God, he's opening a seal file. Ah, he has the power. Or you might even go for double whammy and open an assembler file. Okay, this is just global defines, but still he knows assembler. And then if you want, you show them a picture of the Argon Light, and they're going to say, my God, he's an embedded programmer. And then you hit them with a real one, which is IoT, Internet of Things. It's not exactly the same thing, but it's little things which you cannot program in Visual Basic, and it's hard to find people for. So we're in here, and in the main.c, we're just going to go in, and we're going to change this definition of the RC, the release candidate. I'm just going to change it to a random number 8, just so we can see that it is actually our version that we're running here. So we save that, we build, rebuild all, and normally with other systems, you'd now go and, read War and Peace, maybe build an Ark or something, because compiling kernels takes forever. Oops, we're done, because the Argon Light is such a nice and not sprawling kind of environment. We have successfully compiled the MOS. Now, the output will be, in the default configuration, will usually be spat out into a debug folder, and in that debug folder we got to look for the MOS, the hex file, mos.hex. Here it is. This cannot run directly on the Argon, because the MOS needs the Argon needs a bin file. So let's paste our hex file into the hex to bin subfolder, and let's just execute that. I got in a slightly weird place. Argon H to B, and then we go hex to bin, mos.hex, chunka, very fast, and he's just created a bin file, and here it is. Now we're going to take that, we're going to put it over in our emulator folder. So on the emulator, you don't need to flash, right? I've got a video about how to flash the MOS on a device. Here you just need to drop the MOS into the emulator folder, and it'll pick it up from there. Launch the emulator exe, and ta-da! We now have version 1.04, release candidate 8. Ta-da! We have hacked the kernel, compiled the operating system, and we've installed it. Amazing, impressive, isn't it? And just to show, I did this earlier. I didn't want to delay this, but I've actually flashed this quite successfully to my actual hardware, which you can see there, RC8, live on a real Argon. All right. So why would one do this apart from these totally realistic scenarios which I mentioned? Well, people have been wrestling, for example, game programmers. There were certain things with the keyboard handling they didn't like. Right? You don't like the keyboard handling? Go in the assembler file, fix it, and make an incompatible operating system. Yay, proliferation. Or in my case, I've actually got a pull request which has been accepted by Dean as an enhancement and not slapped back. A bit arcane, but in one of the previous videos, I connected my Argon via a serial port to a Raspberry Pi to get on the internet for multi-user dungeons. Now, the default behavior of the MOS is that when you're using serial communication and you want to read a byte from the serial port, it's blocking. It's like it's going to sit there and say, nope, I'm not doing anything else until I get a byte through this serial port. Well, with a MUD or most terminal emulations, that's not realistic. You're not constantly waiting for a stream. You're going to go in, say, hey, is there a byte? Oh, there's no byte. I will go and do something else. And so made 3-line changes and a few files in here, compiled them, and that's how I was able to do that serial communication. So yeah, that's that. And the purpose of this video was not to be a detailed walkthrough. You should be able to reproduce all of this based on the video, but it's really to take away the fear, right? It's like, oh my God, I'm going to brick my device, and it's so complicated. No, just click Downloads folder, then hex to bin, and you can compile your own operating system. The purpose of this video is to prove that it's possible, so that you are more confident about going down this path yourselves. That's it for today. Remember to follow, remember to like, share, and subscribe. Remember to tell your friends to like, share, and subscribe. If you are a creator, you've got a cool game or hardware or a utility which you'd like me to review here, hit me up on the old Mastodon or down in the YouTube comments or anywhere else. Always hungry for comment. I can't guarantee that I'll do a video. I can't guarantee that I'll say nice things, But in general, you've seen the tone here. We're trying to be civil and positive. So, yep, always welcome for content. With that, all I have to say is that you are a bunch of kernel IoT embedded hack operating systems hackers. Put that on your LinkedIn. And I'm Loserbum. You're all a bunch of bloody legends, and I am out of here if I can find the button.